Okay, so let's now talk about the value of a bond. The value of bond will simply be the sum of the present values of the coupon payments and the principal payment, which especially means that you have to discount back each of the coupon payments and then the face value and then sum them all together. Let's look at an example. This example is different from the one given in the book and it's semi-annual. So now let's see. 10% semi-annual coupon bond maturing in 2 years, while term is 8%. Here are its cash flows, 50 in each of the 6-month period and 1000 at the maturity. This is the discount rate, 4%. So in order to calculate present value, what we have to do is discount back this particular cash flow, which is cash flow divided by 1 plus the discount rate, which is already divided by 2. So no need to divide it by 2. Raised to the power 0.5 multiplied by 2, as we are dealing in semi-annual time periods. You will get 48.08. Okay, so if we drag this, we can find out the present value of all the cash flows. But for that, what you have to do is you have to fix this sales value, and we fix this by inserting this dollar sign. Okay, so when I drag this now, you can see we got present value and even we got present value here. So you can see, okay. In order to find out the price of the bond, what we have to do is just sum or add all of these present values, and we will get 1036.3. This is pretty straightforward. We have been doing this since our childhood, as I used to say, since you studied the IBF. Now, it's very important to understand at this point that there are some very important properties of this present value formula, which we have just discussed. So what are those important properties? So, for example, the first important property of this is that value of a particular cash flow at a given rate will decline as we will go into the future. So for a particular discount rate, the value of cash flow will decline as we go further into the future. As you can see, the cash flow is constant 50, 50, 50, but its present value is declining 48, 46, 44, and so on if we go further. So that's the first important property of this. Second, the second important property is that discount rate, as we can see from the formula I discussed, discount rate and the present value are negatively related. So what we mean, so we calculated these present value as at a rate of 8%. Let's see what will happen if we calculate it at 12%. So it will be 6 monthly 6%, right? So let's modify this a little bit. It is at 8%, and we are here calculating a second present value PV at 12% using this discount rate. Okay, so again, the cash flow divided by bracket 1 plus 6%. Remember, we are now using 12% discount rate. This multiplied by 2. Sorry. So because we are going to drag this formula, let's fix this discount rate. Okay, so 47.16, and when we drag it, so now if I sum these values, we got 965. You can see and feel the difference. So basically, the second property is the discount rate and present value are negatively related, right? Okay, clear. So so it means the higher the discount rate and lower the present value, and vice versa, the lower the discount rate, higher will be the present value. Okay, finally remember the rule of thumb you have studied in IBA, that how to figure out whether a bond will be selling at a premium or at a discount. So we discussed that when the coupon rate will be equal to the YTM, or we can say the discount rate, the price will be equal to par value, right? But if the coupon is less than the coupon is greater than the YTM, as was the case here when we calculated the present value at 8%. The here in this case, the just let me modify this. So if the coupon is less than the YTM, the price will be greater than the par value, or we say the bond is selling at premium, right? Here is the case. It's 8% discount rate, 10% coupon rate, bonds prices 1036. If the coupon is less than YTM, the price will be less than par value, and we say the bond is selling at discount, right? So important three properties of the present value are, for our case of the bond, is for a particular discount rate, the value of cash flow decline as we go further into the future. The second one is the discount rate and PV are negatively related, and the third is related to the relationship between coupon rate and the discount rate. Okay, now in other very important property of the bond pricing is, if we consider only this case, let me copy this here. Another important property is that okay, let me copy both of these. Another important property of the bond pricing is, as we go near to the maturity, as we go near to the maturity, the price of the bond will move towards its the par value. So if it's a premium bond like this, if it's a premium bond, if and we calculate this bond's price uh, after first 6 months, you will see it will be lower than 1036 and so on. And a bond which is selling at discount, its price also will be moving towards its par value, which means its price will be increasing with time. So this is for you guys to practice on this. And if you want to confirm, we have, I think, already discussed this in our class. So in this part, what we did is we uh, uh, discussed the example of a bond pricing and its properties, bond pricing and the properties of the bond price. That's all.